All right, today is Monday, January 24th. All right, today we're going to start off with our week two review to look at the big takeaways from last week's material. Then we're going to review and discuss the FET simulation that was due on Friday. And then we'll do a demo on what happens to temperature when ice melts. There is a quick animation video and then an activity which I will give you, which is a hard copy to explore analyzing phase change diagrams. This is going to be completed in class, and you'll be given a hard copy. If you're absent, you will find a printable copy that I will show you on Canvas. Tonight's homework is to read, highlight, and answer the questions from pages 125 to 129. And then just to let you know, we are quizzing on experiences 1 and 2 of investigation 4 on Thursday. All right, so taking a look at our week 3 module here. All right, here is our review. All right, week 2. All right, so we started out the week with an engagement video and then our correlate material properties lab. All right, key takeaways from what we did at the beginning of the week. States of matter. So ionic bonding is used to describes the attractive force between oppositely charged ions in an ionic compound. Covalent bonds are defined as the net attractive forces resulting from pairs of electrons that are shared between atoms, and we know that they can be shared equally or unequally. And then the third type of bond were metallic bonding, which describes the attractive forces that exist between closely packed metal cations and then their free-floating valence electrons, which we call the sea of electrons. So the purpose of the lab experiment is to examine the two states of matter, solids and liquids, and investigate the link between the types of bonding and the material's state under standard conditions. So that's why we wanted to review these 3 bonding types first. Then after the lab, we looked and read pages really 112 to 123. This is part of what we went over, or the big takeaways. So kinetic theory, particles are always in motion. And we can, see that. All right, due to the attraction force of attraction, ionic compounds tend to be solids at STP, where covalent compounds can be gases at STP. So then we also had gas pressure, and we can see the diagram there that shows us that if we increase the temperature, we're going to increase the pressure. If we increase the number of particles, we're also going to increase the pressure. However, if we decrease the temperature, that's going to decrease pressure. And then if we decrease the volume, we're going to increase the pressure. So that's one that's going in opposite directions. All right. We also learned by page 117 that there are 3 types of motion. We have vibrational, which is that back and forth movement in a fixed position. All 3 states of matter have some sort of vibrational motion. Rotational, spinning in a fixed position, gases and liquids would have that type of motion. And then translational, which means you would shift from one point to another or from the X plane to the Y plane to the Z plane, appears with gases only. Okay. Pages 118 to 123, we will upload onto Canvas shortly. It wasn't there when I was ready to make this video, so I will add that. And then at the end of the week, we asked you to do the FET simulation based on the states of matter. So oxygen, so you looked at 2 substances on the simulation. One was oxygen, and then the second one was water. So oxygen molecules are tightly packed and vibrating in place when we start out as a solid. When energy is added and temperature increases, molecules move throughout the container and now have vibrational, rotational, and translational motion. And when the temperature is decreased, molecules lose that energy and the motion goes back to vibrational only because we get back to a solid. The water molecules, movement-wise, have the same pattern as oxygen. However, water molecules as a solid are close together, but not as compact as what we saw with oxygen. Our liquid water is more compact than solid water, and this is why ice will float on water, because our density is slightly more for water than it is for ice. All right, so those are our major topics for the week. And then the next thing that you're going to be doing today is analyzing phase diagrams. So what I want you to do first is you're going to click on this big long link that said this animation uses examples to show how phase changes occur due to changes in the arrangement of particles at the molecular level at melting and boiling points. So click on that. It's about 2 minutes or so. Once you're done with that, you're going to see this worksheet. And here's the printable copy if you want to print that out if you're not in class today. So you're going to use this information in the phase change diagram for methanol to answer the questions that we see below. Okay. Tomorrow, when you get back to class, if you're not here today, we will begin by going over the analyze phase diagrams. There's no submission for today. This is a let's do it in class and we'll talk about it tomorrow activity. So as far as submissions, there are no submissions on our work for today. Just remember that I want you to read, and let's just review and look at our agenda again. Read pages 125 to 129, highlight, and that's where we're going to begin tomorrow after we go over our analyzing phase diagrams worksheet.